All right, we're going to do a couple quick lessons here on data when it comes to maps. So I wanted to go over this before we actually get into doing actual mapping because everybody underestimates data. Everybody tries to kind of tack it on after they've had their big idea, after they start working on stuff, when really data is so important and it's hard to get across how important it is to have like knowledge about data and what you're going to put on the map and how you're going to get that data in the first place before you start like actively doing some complicated project. It's not to say you have to have everything perfectly sorted, but it really helps to understand about data before we get into doing real mapping. So we're going to do one video here, just kind of broad overview of spatial data when it comes to mapping. And in the next video, we're going to go over like actually how you might get some data and trying to encourage you to not underestimate how complicated it can sometimes be to get data that you think might just be out there. So to start with, just what's about data when it comes to maps. First of all, like I said, data should always come before the map, even if you're just using like placeholder fake data. So if I can't get the data yet, but I know it might be out there, maybe I go to geojson.io, I drop a bunch of points around, and I say, okay, that's good enough. Now I can start making my map with some data that'll be replaced later. But I can just try to like kind of make it so it'll be easy to drop in the new data once it comes. So, but we have to have something to work with. We have to have some data. Just for a quick idea of this, I've opened up a site that I made, which is called Native Land. I built this years ago, and it's got a lot of data on it. It's a map that's showing like different indigenous nations across Canada, first of all, then North America, then now it's the whole world, and it's expanding all the time and that sort of thing. But as you can imagine, there's a lot of data, like where are all these shapes from? Who says these shapes are what they are? What about the names? Look at the names. They're not all instantly readable and that sort of thing. So before the map comes the data. I didn't really have a great hand on how complicated this data was going to be, but I did get started somewhere. I basically just got started in the area where I live. I found some small bits of data and then just added to it over the years. But I had to establish basically some of the core ideas of like, where do I get data? What are some example data that I use? And basically what all there is here is a bunch of polygons, right? There are a bunch of shapes that also have names. So I can turn them off and on, and we get different shapes. And then we get different shapes when it's for treaties. But they're basically polygons that have names attached to them. And that's really the core data. So I could use fake data for this to make it, but actually where I'm going to get the data, how is it going to be formatted, all that sort of stuff needed to come a little bit before I started doing the real map itself. So what are some types of terms or different types of data that we're going to use when it comes to working on our maps? Well, there's GeoJSONs. I've mentioned that briefly here in geojson.io, that this format here on the right-hand side is called a GeoJSON. There's actually a website, geojson.org, which contains the quote-unquote like specification, which is just like the actual details of the GeoJSON and how it was created and how, what the layout of this data is. You don't really need to get into the deep details of that. We're going to use it. It's basically a different way to put coordinates of points, polygons, and lines into a JavaScript friendly format. That's basically the idea behind a GeoJSON, at least in the way that we're going to use it. So that's pretty straightforward. Now, this isn't the only format that geographic data comes in. There's also some other major types, and we can see them actually listed here on the Map Shaper exporting tool. There's some really key ones. Shape files. Shape files are very common. You're going to see shape files all the time. Generally, they come through as a zip file, so as an archived or compressed file that has like a bunch of sub files inside it, usually a .shp, and then like a I don't know what they are, like dbf, and there's a bunch of other files associated with it. So you can export to a shapefile here and actually see one, for example. Let's pop it up. And you can see here, it's all these subfiles that are inside this one unextracted file. So in this case, there's like a whole bunch of them. Normally, you probably wouldn't need to have this many. I don't know why, whatever. Its exporter might be just doing some weird thing. But here's a shapefile. There's also KMLs, that's just another format that's fairly common. There's also CSVs, that's usually used for points, so that's like a spreadsheet. A spreadsheet might have like a latitude column and a longitude column. That's fairly common to see as well. And that's usually our basic ones we're going to run into. GeoJSONs, shapefiles, KMLs, and CSVs. Just so you know, hey, these are out there. Those are the type of data types we're probably going to run into when we're hunting for data or when we get data from someone who's asking us to map it, okay? A couple other terms. OpenStreetMaps, this is basically, this is like a huge, this is an amazing, huge open source project that's just taken on by citizens around the world to like map the world, basically. And it says here, it's a map of the world created by people like you. So this actually underlies Google Maps, Mapbox, and pretty much everything else you see online. Google Maps and Mapbox and these other companies augment OpenStreetMaps with their own data, like Google Maps sends people out to check on, you know, oh, is a new road being constructed somewhere? And then they try to add it to the map, right? Because they have to keep the map up to date and it's changing all the time with construction and natural disasters and things like that. But OpenStreetMaps is usually faster than any of these companies could be because these people are everywhere. There are lots and lots of these people. There are thousands upon thousands of people who map out the world and map out changes. So when there is a natural disaster somewhere, there's usually a huge cluster of people who start analyzing like satellite images and then updating OpenStreetMaps because maps can be really useful in disaster situations. Anyway, all this data is available, but actually getting out this data with something like this export tool can be really confusing because there's so much. You know, you can imagine if I export this data right here, that's a big amount of data, all the places, all the names, all the stores, all the roads, everything, right? It's a lot of data, but it's good to know about OpenStreetMaps and that you can get this data yourself and do what you want with it. A couple other terms, there's a couple types of databases that might be useful to know about. This isn't stuff I'm going to go over in any detail. I might not even mention these again in the course, but just terms. There's, if you're working with databases, there's something called Postgres, which is a type of SQL database. It's just a type of database where we store data, obviously. And it has a little add-on called PostGIS. So if you're ever working with databases and someone asks you, hey, how do I do like spatial analysis with my database? I have all these polygons and points and I want to find out which one is in which, but like, how can I do that in the database? Often that's done with something called PostGIS, which is like a little add-on to a database. Just something to know about. I don't think we're going to go over any more stuff like that. The only other thing I put on here to mention, but I believe I've already mentioned, is projections. So I talked about that a little bit before, that we use the Mercator, the web Mercator projection when it comes to mapping stuff online, which uses latitude and longitude coordinates in degrees like we've used. You don't really need to know much more than that. You can reproject coordinates using different online tools or using something like ArcGIS or QGIS. You can drag in a file and then it's a little bit complicated, but you can go through some options and then reproject because ultimately these systems can all translate one to another. You know, like one place on the world, it's just a measurement of where you are on some grid, and how that grid is constructed can be translated from one to another. So that's basically it for overall, like what is data, what types of data are out there, and some basic concepts. In the next video, we're going to go over an actual example of like trying to grab some data and see how it can be kind of a mess, and hopefully that encourages you to kind of get your data, like get it so that's the first thing you tackle rather than it being the last thing after you've worked a whole bunch on a map. See you in the next one.